Hello and welcome. Are you somebody looking to achieve one of the highest grades possible in GCSE Maths? Well, if you are, please continue to watch, as in this session, we aim to tackle the topic of, I say Surds, but it's an introduction to Surds before we get onto the more challenging concepts of rationalising expressions involving Surds in the denominator. Now, as always, we will be calling upon prior knowledge and previous understanding. So in this session, we will be calling upon your conceptual understanding of simplifying. And when I say simplifying, not just algebraic expressions, but I also want you to consider things like simplifying fractions. In other words, we're not actually changing the value of a fraction, we're just rewriting the fraction, shall we say, with lower digits in the numerator and the denominator. That will be the main conceptual understanding that we call upon in this session. As always, if we do touch upon any topics that you think you might need a little extra help with, please be sure to check out some of our other videos that address those topics. But for now, please continue to watch if you are looking for one of those highest grades possible in GCSE Maths. So in question 1, we're being asked to simplify the surd, the square root of 72. So the way that we simplify surds is by asking ourselves, does the number we've been given have a square factor? And if it does it have more than one square factor? If so, what is the highest square factor? Now, I'm going to just demonstrate this because I think some of you will think, yeah, there's a square factor of 72. It's 9. Now, remember, we're not changing the value. How do we get back to 72? So we'd have to multiply 9 by 8. And some of you might be thinking that root 72 simplified is 3 root 8. It isn't. That's simpler, not simplest, because root 8 also has a square factor. We could rewrite root 8 as root 4 root 2. So that would actually give us 3 times 2 root 2, which gives us 6 root 2. We now have written root 72 in its simplest form. However, we could have saved ourselves a lot of bother, because 9 is a square factor of 72, but it's not the highest square factor of 72. If in the first instance we'd taken the highest square factor of 72, well, that's 36. What do I multiply 36 by to get to my 72? 2. Straight away you can see our answer would have been 6 root 2. So they're both correct, but I'm trying to encourage you to work in the most efficient way possible, because when you're in an exam, you will be under time constraints, time pressures. So let's look at question 2 then. Simplify 8 root 3, subtract 5 root 3. Well, you could almost think of this as, I don't know, 8x subtract 5x. And I think if you were asked that question, you'd be thinking it was very easy. But sometimes this new, shall we say, abstract form of a number, these roots, do cause confusion. But they shouldn't. 8 root 3 subtract 5 root 3 is simply 3 root 3. Now there's a part B to this question. Simplify root 8, add root 18. Now when we add or subtract surds, we must try and think of them in the same way that we think of fractions. You can only add and subtract fractions that have a common denominator. Well, you can only add and subtract surds where the surd is common, and this isn't. 8 is not common to 18. So the way we add surds is by rewriting them with a common surd. So let's have a go. We're going to simplify first of all root 8. Does 8 have a square factor? Yes, it does. 4. So we can rewrite root 8 as root 4 root 2. Plus, well, we can rewrite root 18 as root 9 root 2. And already I can see I've got a common surd here, so I'm quite pleased. So that will give us 2 root 2 plus 3 root 2. Now I can do it quite easily. Think of it as 2x, add 3x if you wish. But 2 root 2 add 3 root 2 is 5 root 2. Let's look at question 3. Multiply root 6 times root 24. Give your answer in its simplest exact form. Well, root 6 times root 24. 6 times 20 is 120. 6 times 4 is 24. 120 add 24 gives me root 144. Oh, 12. A very straightforward question, but calling upon your knowledge of tables and roots and our number system. Question 4. Simplify completely. Now, I've already said a few times, so I'm going to say it again to add that clarity. When it comes to adding and subtracting surds, think of them as fractions in the sense fractions have a common denominator, surds must have a common surd. Now, there are no common surds here whatsoever. So we are going to have to simplify each surd and hope that we get this common surd once we've simplified. Well, root 12 simplifies to root 4 root 3. And I think we've seen root 12 in one of the previous questions. In actual fact, I think we've also seen root 27 in a previous question. We can simplify root 27 to root 9 root 3. Minus the highest square factor of 75. Well, this is lovely because now we have rewritten each surd with a common surd once simplified. But I'm going to break it down further. So in brackets now, instead of writing root 4 root 3, I can write 2 root 3. Instead of writing root 9 root 3, I can write 3 root 3. Subtract, instead of writing root 25 root 3, I can write 5 root 3. This implies 5 root 3 subtract 5 root 3. Well, anything subtract itself. 5 root 3 subtract 5 root 3. 0. Thank you for watching. If we've touched upon any topics you think you might need extra help with, please be sure to check in on our other videos. But for now, the very best of luck in your quest for achieving one of the highest grades possible in GCSE Maths. Thank you for watching.